Okay guys, this is lesson 910 for rotations. Rotations, you're going to want to write this down in your notes. There's 3 key vocab words for this. A rotation is a transformation that turns a figure about a fixed point. So, this would be the center of rotation right here, point P. If you copy this down, the fixed point is called the center of rotation. So point P in this figure is the center of rotation. And then if I had PRQ, this figure, if I rotated it 90 degrees, I have to keep my center of rotation. So I have to keep it on point P, and then I rotate it 90 degrees. Then I would have my new figure, which is called a rotation. This is rotational symmetry. You're taking your one figure and then you're rotating it so it looks totally different. In the diagram, the direction of the rotation is counterclockwise. All rotations in this book will be counterclockwise, so you'll always be rotating kind of to the left or counterclockwise. The angle of rotation is also really important because I'm going to ask you, do it 90 degrees, 180, 270, or 360. It's usually in those 90-degree increments. Okay, so here's a sample problem. Find the vertices of the image of triangle ABC after a rotation of 180 degrees about the origin. So step 1, it says draw ABC on your paper. So try that. Draw this ABC. It's right here. ABC. Draw that on your paper. Now what they want you to do is to take a piece of another piece of paper and lay it over the top, like tracing paper they call it. And it says trace the vertices of the triangle and the X and Y axis. So you're going to trace this over the top. So it's a second piece of paper. I'm tracing over the top of what I already have on my paper. So this is A, B, and C, and you want to label your points. Now it says place your pencil at the origin to rotate the paper. So you put your pencil at 0, 0, and then you rotate the paper. So I'm going to take this paper and I'm going to rotate it 180 degrees. That is not working. So I'm going to do this. Okay, so I have my 3 things. And what you're going to do is rotate your paper around so that your X and Y axis line up, and then you can see that your new figure is in this bottom quadrant, quadrant 3. So it says mark the position of each vertex by pressing through the paper, and then you connect the vertices on your new image. So this is your paper. And then you're going to write down A, B, C. A prime, B prime, and C prime. The vertices of the image, and then you can list out the vertices. A prime is -1, -1, B is -2, -3, and C is -3, -2. So we will try this again in class. I'll go over like how to do it with some tracing paper. Some more key vocab is rotational symmetry. So if I give you an object, so if I gave you this wheel from a BMW, it says and then they ask you, does this have rotational symmetry? And if you can take it and rotate it 180 degrees or less, here's the key part, 180 degrees or less. That's the key number. It can't be greater than, it can't be 270 or 360 because everything has 360-degree rotational symmetry. If you think about it, if you just turn it around, it's going to look the exact same. So that the image matches the original figure. The angle or its measures through which the figure rotates is the angle of rotation. So you have your point of origin, which is your center, and then you look and you see, okay, this has 1, 2, 3, 4, 5 parts. Okay? If I take the wheel and I rotate the wheel a turn, one turn, does it look the exact same? And it does, because look, all my 5 parts match up. So this has rotational symmetry. How you figure it out is a circle has 360 degrees of rotational symmetry, and you divide that by the number of parts of whatever you are looking at. So if it is like this, it has 5 parts. So then it would have 72 degrees rotational symmetry, which means if I move it from here, this green line to this green line, if I move it, it is 72 degrees to get right to the exact same position. All right, so try this. Judging from appearance, state whether the flower has rotational symmetry. If so, what is the angle of rotation? So try this problem on your paper. Tell me if it has rotational symmetry, and then tell me the angle. All right, so this here is my point of origin. This has 3 sides. So if I look at it, it does have rotational symmetry because I can rotate that and it will look the exact same, because all 3 parts are the same. So it has, yes, it has rotational symmetry. And how you figure it out is you would do 360 divided by 3, which is 120 degree rotational symmetry. And if you remember from our notes, it has to be 180 or less. So that fits the requirements. So now try these. Judging from appearance, tell whether each figure has rotational symmetry. If so, what is the angle of rotation? So try these in your notes, and then we'll go over them. All right, so let's look at this first one. If I put my center of rotation here and I rotate this figure, so I'm going to trace it. If I rotate this around, okay, does it look the same? No, it doesn't look the same. When I get there, it does not look the same. If I rotate it 180 degrees, it doesn't look the same. But if I go 360, it does. So the only way it would have is if it's 360. So that is a no, because it has to be 180 degrees or less. If I look at this one, I rotate my figure. Okay, I rotate it 90 degrees. That is not rotational symmetry. And if I keep going, there it lines back up, and that is 180 degrees. So that is yes, and it has 180 degree rotational symmetry. And then lastly is this one. And then I rotate it. Well, that doesn't fit. So if I keep going, does it fit again? And yes, it does if I move it there. So yes, this has 180 degree rotational symmetry again. So that is it for your notes.